All right, estimating quantities. And, you know, really this lesson in the grand scheme of things, maybe a couple questions on your test. 8.6 and 8.7 carry a lot more weight. But it is important for us to kind of set the tone or, you know, start off the scientific notation concept with the estimating part of it. Okay, so one way to approximate. So what you're going to see today is really, really big numbers and really, really, really tiny microscopic numbers. So it's either going to be really big or really small. We can round that number and write the result as a product of a single digit and a power of 10. So one thing I need you guys to understand is every place value. All right, so I have the ones place, the tens place, the hundreds place, the thousands place. Every place value is what we call a power of 10. Once you get up to 10, what happens? It bumps up the next digit up by 1. For example, 110 equals how many ones? 10 ones. Okay? 10 tens equals how many hundreds? 100. 10 100s equals how many 1000s? 1 1000. So that's why we have a power of 10. All right. Okay, so approximating a large number. The volume of water on Earth. I want you to think about that for a second. We're talking all of the earth, all of the water on Earth, oceans, lakes, rivers. I want you to look at this number. 332,500,000 what?
Cubic miles.
Miles. Cubic miles. So that's length, width, height, depth. That's a lot of water. Do you know how much of the Earth is covered in water? 75%. Very good. 75% of the Earth. That's a lot of water. So what we're going to do is we're going to take this number. Would you agree that's a really big number?
Yes.
It's a pretty big number. We're going to take this number, 332 million. I want you to write it down. 500,000. And we're going to round it to the leading digit. The first digit we see is 3. The next digit after that is another 3. So the second 3, all right, here's my rounding rules. What is that little saying that y'all learn in elementary? 5 or more, raise the score. 4 or less, let it rest. Do you guys remember that?
I ain't heard it.
Okay. All right, so that's just, I don't know, that came from somewhere. All right, 5 or more, raise the score. 4 or less, let it rest. Leave it alone. So 3 is 4 or less, so I just leave it alone. 3. Now I'm going to times that by a power of 10. Each place value is a power of 10, just like we just said. 10 ones equals 110. 10 tens equals 1 100. So I'm going to count how many place values are behind my leading digit. I go 1, 2, 3, 4, 5. So this is times 10 to the 5th. And what I'm doing there is I'm saying there are 5 powers of 10 behind my leading digit. 3 times 10 to the 5th power. All right, next example. A blood vessel. So think of your blood vessels in your body. They're microscopic. It has a diameter, the entire distance across a blood vessel, 0.0000924 meters. Well, first of all, the first problem is it's expressed in meters, right? It should be millimeters, right? Okay, we'll talk about that later. I don't think that's in this example. So round the diameter of the blood vessel to the leading digit. So we're still going to use leading digit. And write the result as the product of a single digit and a power of 10. All right, so the first non-zero number that I see is a 9. the number behind that tells me what to do with the 9. The number behind that is 2. So am I going to let it rest or am I going to raise the score? Let it rest. Right, Tyler? Let it rest. Okay, so 9 times 10. But now something different is happening. This is a really, really small number. This is going to be really important for your lesson tomorrow. My power is now negative. My power is now negative. Correct, the decimal's in front of it. So now you need to figure out how many place values, okay, so you're moving your decimal after the leading digit. So how many place values are going to be absorbed in your powers of 10? All right, you're going to count them. 1, 2, 3, 4, 5. There are 5 place values now that get absorbed or basically that, to move my decimal behind the 9. So 9 times 10 to the power of negative 5. Guys, do you understand why 10 is my base? Because each place value is a power of 10. Why is it a power of 10? Because it takes 10 of those digits to equal 1 of the next digit. That's where we get our power of 10, our base 10 blocks that you learn when you're in elementary. Okay, Taylor?
Will we ever have to make the exponent positive?
The exponent's positive when it's a really, really big number. The one that we just did in example 1. So if it's a huge number, my exponent's positive. And I get what you're saying. No, don't worry about having a negative exponent. Yeah, so she's saying, because remember in our last lesson, we don't want negative exponents and we got to get rid of them. Don't worry about that here. What my negative power is telling me is that this is a tiny, tiny, tiny number. If I didn't know what the example was and I look at this, I know this is a microscopic number. Okay? That negative exponent tells me that. So we're not worried about keeping it negative. Yes, Talina.
Okay, wait. So when it comes down to like figuring out what the exponent is, so like I understand like all of like the zeros.
Yeah.
Will like.
Yeah.
Will, like,
Place value.
So like with that, like all them zeros also be like the same number as if you did do all the, because when you did the thing before, you didn't include all of the zeros. You like cut off the other 3 and like counted it until you got to the.
Right, but because this is a negative number, because it's a tiny number, I got to go the other way. So are you talking about the 0 in front of the decimal?
Yeah.
Yeah, that one doesn't count because I'm moving the other way.
Oh,
So that one doesn't count.
So
It's from wherever the decimal is.
Okay.
Yeah. Okay? All right, the more examples we do, I think the more it'll make sense. Did I just skip one? No? Okay. All right, example 3, Saturn. Distance from Saturn to Neptune. Have y'all ever watched those videos that talks about like how vast the universe is? And like it makes you feel like this tiny, insignificant like speck in the grand scheme of the galaxy. Okay, this is one of those examples. The distance from Saturn to Neptune is about 1 trillion. Can y'all read place value? 911 billion 674. No, wait, it's 1 million. Billion, million, thousand, and then hundred. You know what I meant. Okay, it's not trillion. All right, the distance from Mercury to Neptune is about 1.5 times this distance. What is the approximate distance from Mercury to Neptune? Okay, so here we go. The first thing we're going to do is round to the leading digit. Okay? We're not going to worry about all those digits. Clearly it messed me up because I thought it was trillion and it was billion. All right, so the 1, what is the 9 behind it telling me about what I should do with my 1? I need to round it up. Round it up to 2 times 10 to the power of how many powers of 10 are behind my leading digit? 9. Okay, so 2 times 10 to the 9th power. Now, if the distance from Mercury to Neptune is 1.5 times that, you're going to multiply 1.5 times 2. Okay, and 1.5 times 2 is 3.
Wait, how did you get 2 again?
I rounded it to the leading digit. Okay, so 3 times 10 to the 9th power. Option C.
So, Miss.
Just don't do that. Okay, population of the Philippines. Okay, it's about 104,260,000. Population of India is about 1,282,000,000. All right, I got the place value right on that time. Approximately how many times greater is the population of India than the Philippines? Okay, so what you're going to do is you're going to round each one to the leading digit. So for the Philippines, okay. All right, the Philippines, I know what you did. Don't do that. Round it to the leading digit. 1 times 10. How many powers of 10 are behind my leading digit? How many powers of 10?
8.
There are 8 powers of 10. 10 to the power of 8. Okay? All right, now I have India. Okay? India equals 1 times 10 to the how many powers of 10? Yes. Okay? Are behind that digit. So what is the difference? Okay, what is the difference in the powers of 10 when you subtract? All right, so there's 1 power of 10. So this is going to be 10 to the power of 9. Huh? What's not right?
It's not running on the board.
I haven't wrote anything else.
Oh, I thought you were like, I saw
1 times 10 to the power of 9 over 1 times 10 to the power of 8. Okay, so I'm dividing here. 1 divided by 1 is just 1. 9 minus 8.
Is what?
All right, so 1 times 10 to the first power. Well, what's 10 to the first power? So their population is 10 times greater. 10 times greater. The bottom line here in this lesson is that you understand place value and powers of 10. That's all of what scientific notation is about. Taking really, really big numbers and really, really small numbers and writing them in a shortened way. All right, so again, this is kind of like your building block for scientific notation. Is that the last example? Okay. All right, so we're going to take the rest of class to work on your big ideas.